All right, this time we're going to try 55 about the lighthouse. The lighthouse is 2 kilometers from a point. That part's not changing. Along a straight shoreline, and its light makes 1 revolution per minute. How fast in kilometers per minute is the beam of light moving along the shoreline when it is 1 kilometer from the point P? So the way I would start is think about what is it that I'm looking for, what do I know? I know that 1 revolution per minute is another way to say 2 pi radians per minute, because 2 pi radians would get it all the way around. I'm looking for a change in distance of p, and I know something about radians, and I'm talking about this beam of light going all the way around here. So I'm really thinking about the relationship between theta, the angle closest to the lighthouse, and I know this distance 2, which I consider an adjacent side, and the opposite side is what I'm interested in. So what I'm going to look at here is tangent. Tangent of the thing that's changing is the top, I'm going to call that x, over, oops, tangent of theta equals x over, 2 is not changing, so I can go ahead and put that right in. Now I'm going to differentiate both sides so that I have, the derivative of this one is secant squared theta times d theta dt. And the derivative over here is going to be 1/2 times dx dt. Dx dt is what we're looking for because that's going to change in this horizontal distance. I think I know the other stuff. If I find that angle theta, it turns out to be, actually I don't even need to find that angle because I know the secant. Secant, remember, is 1 over cosine. Cosine is adjacent over hypotenuse. So this is the hypotenuse over the adjacent side squared, which the hypotenuse I can figure out quickly to be square root of 5. 2 squared plus 1 squared is 5, square rooting that. So this is square root of 5 squared times d theta dt. Well, do we know how much the angle changes in 1 minute? We do. It changes by 2 pi per minute. And we know that equals 1/2 dx dt, which is what we're looking for. So, filling in the steps here, square root of 5 squared is 5, times 2 is 10. So I have 10 pi equals 1/2 dx dt. Oh, I forgot my adjacent side. My adjacent side up here is 2. So this will be 5/4. I'm sorry. So this will be 5/4. 5/4 times 2 pi equals 1/2 dx dt. Multiply that 2 over to this side, and we'll just have 5 pi equaling our dx dt. So 5 pi should be your final answer, which is D.